So this session today is going to be, as you can see, about the Data Hub performance optimization, and I am certainly not going to be your speaker because I'm in marketing. So I'm going to hand it over to our very able speakers. James Clippinger is going to start, and Aaron Miller is going to, I think they're going to tag team back and forth, and I'm going to let them introduce themselves. So without any further ado.
Great. We're already mic'd up. Thank you very much. I'm James Clippinger. I'm the Vice President of Strategic Accounts, and if you ask yourself if they don't let marketing speak about performance, why are you listening to some sales guy talk about performance? I actually wear a number of different hats at MarkLogic. I've been with MarkLogic for 12 years. I've worked with our customers pre-sales, post-sales, public sector, EMEA, North America, everywhere. A lot of the people in this room, I've worked with you or your companies on performance issues, and I tend to work with our customers who have their most complex situations, the most interesting applications, the weirdest stuff going on. And I'm going to be talking with my colleague Erin Miller, who will now introduce herself.
Hi, I'm Erin Miller. I run our performance and reliability group out of headquarters, so that's part of our engineering division. Prior to that, I worked in the professional services group, so I worked with a lot of our customers as well. As Clip says, also with the weird problems. That's what we like. So I've been with MarkLogic about 10 years, and I think I particularly focus on some of the challenges that customers have as they're trying to scale up their environments, and the sort of tips and tricks that we can offer as a lifeline. Turn things over to Clip.
And now we will get on with the show with Data Hub performance optimization. So what are we going to talk about today? We're going to talk about what to check when your data hub is slow. And first and foremost, if you don't think of yourself as having a data hub, if you're using MarkLogic, you have a data hub or something that looks enough like a data hub for performance purposes that all of this will be applicable to you. Then is your area of concern code or infrastructure? I don't want to call it a problem yet. It might just be an area of interest. So finding infrastructure problems, there's some really great new features in the product for that. Tracking down resource bottlenecks, figuring out slow harmonization processes. This is the #1 performance issue we see now with data hubs. And then figuring out a slow production application. So this is a less common issue with customers, but it's the thing that tends to cause your phone to ring if you're a MarkLogic DBA or developer, because if the users aren't happy, ain't nobody going to be happy. So let's start with infrastructure performance. And this is our infrastructure performance checklist. And this information has changed a little bit in recent years. And please note that the recording is going to be online, so you're perfectly welcome to take pictures, but don't strain your neck, don't hurt yourself, please. So these are the things we think you should check first. And we're going to be going through each of these. Your MarkLogic version. Are you running a recent version of MarkLogic? What are your performance expectations? Are those expectations reasonable? Maybe they are, maybe they're not. Let's talk about what feeds into that. What's in the error log, and particularly some very useful new error messages that have been added to more recent versions of the product. Then it's a matter of finding your resource bottleneck, and how historical meters is a very helpful way to find those problems, but also how you test to find those problems, and how you figure out where these bottlenecks are. And if you don't have a bottleneck, well, maybe you just need to put more traffic on the server. Maybe you just need to increase your workload, or maybe you need to isolate your workloads because your different workloads are causing you to lose track of what's actually causing your performance issues. So let's start here. Can I have a show of hands of everyone who runs MarkLogic in production today? All right, now keep your hand up if you're on MarkLogic 9. Okay, how about MarkLogic 905? Relatively few hands up for MarkLogic 905. MarkLogic 905 came out a year ago, okay? We've done a lot of really great things to the product, and we're incrementally releasing a lot of features these days. So if you're on an older version of MarkLogic, your very first step should be to upgrade when looking at performance issues, if you can help it. I know that many times there's a production environment you can't upgrade. There's schedules holding you back, there's testing, all these things. But if there's any way, even in a side environment, you can go and test a newer version, it may be that the performance issue has been fixed, or it may be that there's a metric that tells you what the performance issue is. And we'll be seeing some of these log messages that have come in recent releases that give you a much better read on when you have an infrastructure problem. And they turn it from a real trying to figure out what's going on, testing, looking at various things to, oh, the server is telling me exactly what the problem is. So please, please, please upgrade, and please do this instead of spending your time chasing a problem that may have already been fixed. And I know a lot of you who work with our support team, one of the first things they'll ask is, hey, can you try upgrading? And they're not doing that just because they're obsessive compulsive, although I see the support folks back in the room, they are a little obsessive compulsive, but in a good, positive way. They just want you to be on the most recent release, so they're not chasing their tail either, and they can help you find the real problem. Next up, performance expectations. So there are 5 key resources used by MarkLogic. These are disk bandwidth, disk space, CPU, RAM, and network bandwidth. And you generally need to figure out how much of these you need. The good news is for ingest, if you read inside MarkLogic server, if you read the resource consumption white paper, we don't call it the resource consumption. Understanding system resources, thank you very much. We internally call it the resource consumption white paper, but it's understanding system resources. If you read these and you're doing ingest and harmonization, you should be able to get a pretty good feel for how much of these resources you'll need and what type of system size you'll need to work with. So make sure you have that infrastructure, and then if you think you're in the right range, get that infrastructure and test it out, do the math. If you look on our website, and actually there's going to be links coming up to this, there's the performance testing with MarkLogic white paper, which tells you how our engineering team thinks you should performance test your applications and be able to tell what kind of performance you're going to get out of MarkLogic. Performance testing is the only way to know how MarkLogic is going to perform for you. Everything else is somewhere between an educated guess and a coin flip. And I'm happy to flip a coin for you, but it's much better to test it, and let's be engineers and let's figure this out. So please keep that in mind. And then because of this, and because it's relatively easy to predict what your resource picture is for ingest and harmonization and for reindexing, you shouldn't be surprised by those requirements. And reindexing is when I bring up, sometimes new releases of MarkLogic require reindexing. Sometimes your code requires reindexing because you're adding range indexes, you're adding TDs, all these sorts of things happen today where you're going to need to reindex. You need to keep in mind that you need adequate system resources to be able to reindex your database along with ingest and harmonization and other things. That can sneak up on people. You don't necessarily need to be able to reindex everything in hours. Many customers take days or weeks to do a reindex, but you need to make sure it meets your business requirements. All right, so you have reasonable expectations, you're running on a recent version of MarkLogic, you're still not seeing the performance you expect. This is going to be really dull. Read the log file. Read the system error log. It is your best resource. It is your first resource. We see so many issues with customers these days where they do a bunch of analysis, they think it through, they figure it out, and then we pop open the log file and we say, actually, it says right here your disks are slow. And it's like, well, how slow? Well, it took them 12 seconds to write a kilobyte, so that's really bad. That's not going to do it as far as a responsive database application. So look in the error logs. We'll be seeing examples of these for slow messages. These are disk writes, disk reads. Fsyncs. Fsyncs are very important to MarkLogic because when MarkLogic journals information to the forest journal, it Fsyncs it to push it out from buffers and make sure it's written to disk. So often your writes will run perfectly fast because they're writing to memory. It's the Fsync that gets slow if you have resource contention or a resource starvation in terms of disk bandwidth. Memory messages. This is another new feature in recent releases where MarkLogic every hour will tell you how it's using its memory. And if there's a problem, if it's using too much memory, if it's going over your physical RAM capacity, it will tell you that. So it's no longer that you just need to look for swapping. You actually have primary evidence that this memory issue is about to happen. It's coming up. You can watch those info level messages to see when it's going to happen. And then when it finally tips over, you'll see warnings about what is actually pushing it out of the memory. And then hung messages. And these have been the product for quite a while. But a hung message means the process that runs MarkLogic has a thread that wakes up once a minute? Is it a minute or a second? Second. OK, thank you. These are becoming less common, which is part of why I don't remember. wakes up once a second, sees if a second has passed. If more than a second has passed, I think 2 seconds is the threshold, then it logs out a message basically saying that the process has gotten no cycles in that time. There's been no cycles scheduled for the process sufficient to be able to run the thread where all it does is wake up and see if time has passed. So yes, that's becoming a less common issue, but it's still something to check for the log files because it means something is very wrong with your infrastructure. So if you look at a log here, so here's an example of a traditional log message that tells you have a problem. You don't have enough disk space. Who here considers it a critical issue to be out of disk space on MarkLogic? That's good. I see a lot of hands. I don't quite see every hand, though. If you run out of disk space on MarkLogic, you have to go get more disk space. And that may be very difficult. You may need to move your forest to different machines. You may need to move to a whole different infrastructure. It could be really bad. So please don't run out of disk space. Monitor your disk space. This is the thing that you tend to hit the wall with in terms of performance, rather than it being something that just slowly degrades over time. So now here's one of these new slow Fsync messages. So what this is saying is, just referring to my own slide here, which is always good, the system went to do an Fsync of a label file, and label files are tiny, and it took 2 seconds. That's far too long for an Fsync to take on a small file. And then it goes on, it tries to do an open on a label file, that took 1.6 seconds. Should a file open take 1.6 seconds? I hope your answer is no. If not, there's perhaps a non-performance talk that would be more fun. Then there's also a slow U-time warning. U-time is a system call. It should return very quickly. It's taking 2 seconds. This is indicative of a system that can't talk to its disks quickly enough to support real-time operation. This is a severe issue, and it's one that really MarkLogic can't do anything about aside from reducing its own usage, perhaps helping the issue. And we see these sometimes where they're driven by resource consumption. They also just happen sometimes because of the way the infrastructure is set up. So maybe you're cruising along, you're barely using the disks, and all of a sudden you get a slow Fsync. So just be aware that it happens even on systems that don't seem to be stressed. It may be because your VM infrastructure is stressed. It may be because you have a bad cloud instance. We've certainly seen on AWS it's rare, but you'll get an instance where it just doesn't perform and you need to go out and get a different instance. So these things happen even if you don't expect to have an issue with them. Then deadlocks. So this is another case where looking at the logs gives you some hint you have a problem. Now deadlocks are not necessarily bad. So these are detected deadlocks. These are the server detecting that the deadlock condition exists and retrying the transaction, which on one hand means, hey, the server's working as designed, this is great. But also means you're doing some locking activity that's potentially causing a deadlock. So this could point to code changes using lock for update. This could point to lock contention. If you don't expect to see deadlock messages and you're seeing these, it suggests you have lock contention in your code that you're not aware of. And that's a real concern. That's going to limit your scalability. So that's something to look into if you see the deadlock messages. All right, so you've checked the logs. They're perfectly clean. They have nothing in them but all of the forest merge messages. Everything looks good. Everything seems pretty cool with your system. What do you do next? You look for resource bottlenecks that are visible in meters. So in terms of disk bandwidth, on the cloud, it's easy. On the cloud, the public clouds document how much disk bandwidth you should expect to be getting from your volumes. And our experience is that what they document is pretty close to what you get. So check your bandwidth, check your IOPS, make sure they fit within what your expectation is. It could be you're exceeding that, in which case you have a disk bottleneck that you've created. If you're on-prem, our gold standard is to use a tool called FIO for I/O testing. On the support website, there's a knowledge base article explaining how to use it and what our recommended settings are for it. This will give you a baseline, and it's great for dedicated infrastructure. So if you have bare metal machines running local disks, this will give you very reliable test results. If you're running VMs on a shared NAS, I can't tell you what's going to change with your disk bandwidth in the future. You can't tell me what's going to change with your disk bandwidth in the future. There's no real good information on that generally. So you could try testing, but it's not going to give, it's going to give you a baseline. Whether it's going to give you the baseline when you run your next set of tests, who knows? It's the curse of shared infrastructure. We do sometimes see customers running in a QoS setup where they get fixed bandwidth for each of their VMs. That's rare, but it can happen sometimes. For CPU, I often talk to customers who say, well, my CPU is at 85%, so we can go 15% higher, right? And I could tell from some of the chuckles in the audience that you've had to explain to customers too that a parallel system is not going to be able to fully load every single CPU at the same time. And if it does, it's going to be unresponsive because there's going to be so many requests piled up waiting for those CPUs. So just keep in mind 80 to 85% is max that we tend to see. And then look at lock wait load. This is a phrase I find hard to pronounce but very useful to think about, where you want to see, does your locking activity conform to your expectations for your code and what it's doing? So this is relatively low on the list, you'll note. This is a rare thing to point to something, but I have worked with customers where I've said, geez, you know, your lock wait load is really high. And based on your description of the code, it shouldn't be doing that much locking. It definitely shouldn't be waiting around for locks. And then we find a shared file a shared document that's being used for a bunch of things. We find something that's being used in a weird way that we don't expect, and it starts to explain itself. So my favorite way to look at meters is actually through Excel, because I'm a nerd. And if you do a CSV export into Excel from historical meters, you get a file format like this. You get tabs at the bottom describing each metric, and then you get observations that are the series it observes, the timestamp, and the value. This isn't that useful most of the time because it's pretty ugly. It's kind of hard to work with. But if you use the pivot table feature in Excel, and this is the nicest thing I'm going to say about Microsoft product in this presentation, and if any of the Azure people in the room, I'm sorry. This breaks it all down, gives you an hourly summary of these values. You can get sums, you can get averages, you can get maxes, you can get minimums. If you're a performance nerd, you probably want to be working in a tool like this to be able to analyze the data and really find the time slices you want, get the data format how you want, and pivot tables are a great way to get there. All right, you've done all this stuff. You've established there's no infrastructure bottleneck, there's nothing in the error logs, you've upgraded to MarkLogic 9092, which hasn't even been released yet, but you know someone at headquarters who slipped you a copy, and there is no bottleneck. I don't think there's one scheduled yet, so yeah. Still no bottleneck. Crank up your workload. Get more client threads on it. Make sure your client machines aren't having a bottleneck. Maybe your client machines have run out of CPU. Maybe your client machines can't read from the disks fast enough. Maybe something's happening that means you're not giving enough workload. And then also try increasing the app server or rarely task server threads, more commonly app server threads in MarkLogic, to bring more work to the CPUs, bring more work to the disks, basically open up the floodgates. And then you really want to focus on getting to a bottleneck, and that may mean isolating your workloads. So maybe you need to try ingest separately from harmonize, separately from queries. This is pretty rare you have to do this because generally at this point we found the issue, but sometimes we do need to isolate things out to figure it out. And if there's no bottleneck, your request rate stays the same, it's a real mystery to you, please contact our support team. They're happy to help you walk through the steps to figure out what could be going on. Could it be a product issue? Could it be something that you're just not quite seeing? Because I know certainly you get some target fixation when dealing with performance issues, and they'll help you go from there. And with that, I will hand things off to Aaron.
All right, thank you. So as Clip said earlier, even if you think you're not running a data hub, you're running a data hub, and that's true, but you also might be running the data hub, capital D, capital H, and that's the product framework that we ship. So I'm going to be talking a bit about that. And what we're going to be focusing on today is the harmonization portion of this. So up in here, you've got your as-is data coming in via ingestion. A lot of our challenges in terms of performance come in this center area. When you're going from as-is to curation, you're trying to understand why things might be running slower than you expected. So that's what I'm going to be talking about. So what I'm going to do is I'm going to go through a couple of scenarios. This first one is that, harmonization is slow. And so, as I said, this is that process of transforming your content from as is, however you're ingesting it, the raw data that's coming into MarkLogic, and as you're transforming it into the data format that's optimal for your application. Clip talked about, expectations. What are your expectations? And I think one of the things that sometimes happens is people say, oh, but the ingest was really fast and the harmonization is really slow and I don't understand. There's this disconnect. And so I think understanding what the harmonization workload is doing is really key to this. And of course, always understanding your SLAs, right? That's what everyone is always, it's like we've got to get it into this frame or we're not going to be able to go to production, or we're in production, we've got SLAs that need to be enforced. So, in terms of how do I start figuring this out? I've just got this data hub. You saw the diagram. It's like so nice. It's this great big box. And now what am I supposed to do if I'm having trouble understanding what's wrong? So often one of the challenges that folks first get hit with is, okay, is this a code thing or is this an infrastructure thing? And so as Clip was describing, a lot of the different ways that you might be bottlenecked by your hardware or your cloud. If you're using cloud, your instance types, right? So how do you figure out what's code and what's infrastructure? And what I really encourage folks to do is to use this use methodology. This is a guy by the name of Brendan Gregg. He's a performance expert at Netflix, and he's done tons of independent work around performance. So for everything in your architecture, you want to focus on utilization, saturation, errors. And what's so great about this is that it's so simple. It's like, instead of you're like, okay, well, wait, but the forest merge, and then there's that min merge rate, and then there's, and you can quickly sort of dive into these details. And instead, it's like, wait, let's go up a level. And as Clip just mentioned before as well, often you might have done a deep dive into your environment trying to figure out what's going on, and you open your error log, and it's like, oh, half the forest failed over because that host went down. Okay, I guess that test isn't valid. So there's a certain amount of understanding that errors, looking at errors are a good place to start. And Clip also mentioned these system resources you want to focus on. So, okay, I can see that, I'm trying to figure out how do I start. I start, of course, with the errors, right? Look at the error log. Everything looks okay in the error log. I'm not seeing errors there. So, okay, what do I do? What do I do? How do I know what's going on? I just know the overall rate, what's happening. So in 907, we released a feature called request monitoring. Request monitoring gives you fine-grained information about every single query, and it writes it out to a log. And if you like Excel, you can import that log and create a pivot table. For those of us that like RStudio, maybe we could use that tool as well. But basically, what it does is it provides you a text file that you can use however you want, if you want that level of detail. I just have a link here to the docs because it's a newer feature. I just wanted to make sure I called out where it was located. And the output goes to the usual place, except you get your app server port request log.txt. So what's in there? Actually, let's start with how you turn this thing on. So looking at the thresholds, for this example, I just want to capture stats about all the requests that are longer than a second. So it's actually this really simple. It's called default.api. I'm putting this request on my Data Hub final and my Data Hub staging app server, so I can see that process, right? The staging is just where your ingest data goes. Your final is the output after you've done your transformation. So if you put this in the root directory of your app server, and again, this is a very simple example, and you'll see because it's so simple and it has just one constraint, it gives us very verbose output. So I've dropped this in my root directory. I then am going to run my job, my flow, and I should also mention that this particular example is Data Hub 4.3. I'll talk also a little bit about 5.0 and some of the changes there. But here's my Gradle command. All I'm doing is I'm running a flow, and in this particular case, I'm doing a join of some web page data from the Common Crawl repository, which is basically just the internet. So we've got some HTML page data, and I'm joining that with some geospatial data based on the IP locations. So here's my job. I kick it off. I want to see what's going on. Now this is a very verbose line of logging. This is what your request log will look like. Because I'm taking all this stuff and I'm manipulating it in RStudio, I want a very verbose log because as one of my colleagues says sometimes, I don't know what I'm looking for until I find it. So when we're kind of trying to figure out what might be going on, it's nice to cast a wider net. In this case, the important things that are jumping out is that this flow, this join, was taking me 112 seconds. My circles got messed up again. I'm not sure why that happened. But they're not supposed to be on the library module cache. That's right, that's what it is. I wouldn't use Excel. Oh, man. They are, so what I was actually pointing out here, or trying to point out, so our write locks are 200. And that I would expect, because I specified 200 as my batch size for the data hub. But what I don't expect is my read locks are 48,470. So wait a minute, what's going on there? And then I see my lock time is also quite high. So, okay, that gives me a clue about what's going on here. So just to talk briefly about transactions. So Data Hub and transactions. In 4.3, and earlier, you have these different plugins that you're writing, and those plugins are used to help you transform your data from the as-is to the curated data phase. You've got the main collector, content, header, and triples plugins, and all of those run in query mode. And what that means is that when MarkLogic is running those transactions, we don't get a write lock on all the databases. On all the fragments. We just get a read lock. The writer, where we actually commit the transaction and write the final document, is in update mode. So if you do a search in the same same transaction context as your writer, in your writer plugin, you end up locking all of these documents. The good news is that in 5.0, you don't even get the option to make this mistake. We'll handle the actual write in its own transaction separately outside of the framework. So all you need to do is basically get the document to the point where you want to write it, and then we handle that for you. So now we get to my code, which, as you can see, I'm doing a search inside my write. And because I'm doing a search in the context of an update, I end up locking these 10,000 documents with a write lock. So now I've written some sketchy code, and you can see how the request monitoring helps you figure that out. All right, going to another scenario. What I want to talk about now is the scenario where your production application slows down over time. And this is something that I think a lot of folks have experienced. Everything was working fine for a while, keep loading data, and as I load more and more data, I'm starting to miss some SLAs, I'm starting to see some performance challenges. So once again, focusing on your use methodology, right? Characterize the problem. Did this happen overnight? Was it, because sometimes what we do see is there's a code change that was introduced that just, like the one I just showed, that just blew up your whole infrastructure. Or is this something that's been happening slowly over a period of time? And so, understanding too that you've got, typically you're doing your ingest and you're doing your harmonization, and you're also searching your database all on the same infrastructure, shared infrastructure. So what we do sometimes see, or coming into our support call, is, gosh, when I'm okay when I search my application, but as soon as I run my harmonization job everything slows down. And so again, you're trying to figure out code or infrastructure, right? So typically, the answer is it's typically both. And I think what we do in terms of that use scenario, right, is once you're sure you don't have errors, you're looking at your utilization. And you might look, and as Clip pointed out, you know that you're running out of CPU resources. And so the first thing I think as a performance engineer is, why? Why am I running out of CPU resources? Do I actually expect to be running out of CPU resources? Or, is this, and again, it's about characterizing the pattern. Is this something that's happened slowly over time? Is this a sudden code change that might be blowing out my CPU? Is there anything I can do to tune my code to make it tighter so that I can reduce the computing load? So in this particular scenario, what I am going to assume is simply that you found an infrastructure bottleneck. It's not like the previous example where we had a coding issue. In this particular case, what I'm looking at when we do find an infrastructure challenge like that or bottleneck is you want to look for your hockey stick, right? So you want to look for this point where all of a sudden you see this response time graph and it's scaling linearly nicely, and then all of a sudden it's like boop, so you get this hockey stick shaped graph that's showing you, oh my gosh, you just hit a bottleneck. And so at that point too, we need to think about what part of your infrastructure is causing the bottleneck, right? And it's drilling down using the meters and the monitoring history, CPU, often memory can be a challenge, and sometimes slow disk. Sometimes you might even have a failure, like a disk failure that's causing some sort of anomaly in your testing. So one solution here, and again, this is a scenario where you've just got more and more content over time. You finally hit the point where, let's say you're memory constrained. So you have range indexes enabled, you have more and more data in your forests. You hit a point where you're really using a lot of memory, and you don't want to start swapping, right? You want to be able to support all of the queries that you've got. So one strategy here is to archive some of your data. And all of your data is using resources, which is important to remember. So it's memory, it's storage in particular, and of course disk space. And there are impacts on search as well when you've got very large forests with lots and lots of documents. You might have larger term lists depending upon how your data is indexed. So if this, there are certainly use cases where there's data that you might be critical, but you might not query it that often, right? So it's important, but you don't need it every day. And that's a great use case for our tiered storage feature, and actually was at a presentation earlier today where someone was using this. So you've got, like super fast flash disk for the most frequently accessed content. And then for older content, you could kind of, basically move that onto slower disk. I also want to recommend using S3 or Azure Blob Storage, just because even if you're running on-prem, they're cheap, easy ways to back up, archive data, basically, and it's a good storage mechanism. So putting this whole thing together, there's some basic, sort of good practices for writing code, and there's actually a performance testing white paper where we talk about this. You want to keep your requests independent, and by default, DHF will do this for you. It'll help you with this request isolation. Obviously, locking, we've talked about a little bit. That can be a performance drag. And you want to avoid unnecessary bottlenecks. And in distributed computing, creating a serial number generator might be a bottleneck. You might not need it. There's other things you can do in terms of limiting the request resources. So are you using SQL or Sparkle? You can use the Optic API to limit the scope of your query if you're finding that you're writing queries that are blowing out all your memory. If you have a really large result set and you can paginate, then paginating is a great idea. And Basically, you want to think about, okay, as I'm writing queries, I don't want to write queries where the result set grows with the size of the data. Now, sometimes you might need to, and that's okay. But if you're trying to maintain SLAs and they're very tight, this is an area you want to kind of think about. So if you're querying for all the trades in the database, what happens is your database gets bigger and bigger. So, and if you do need to do this, often an effective way to do it is to batch. So putting it all together, basically you want to use that use methodology, and I highly recommend checking out Brendan's website and reading some of his white papers. Realistically, typically there's a combination of stressed resources and unoptimized code that contribute to performance problems. And to try to separate these out and figure out what's going on, using the use methodology is a great, kind of easy to remember way to do that. As far as scaling goes, when you're writing your application, you know you're going to want to scale it over time. The first thing to do is to optimize your code as best as you can, to try to find those bottlenecks. Use our profiling tools to figure out, is my code running slower in certain areas? Why would that function be running so slow? So basically using our basic debugging tools to optimize your code. And then once it's as tight as it can be, then you can look at adding infrastructure resources. Finally, I just put together some resources for you. The first thing I want to say is our support team is excellent. They handle a lot of our performance traffic. And the other thing you should know is that when you send an email to support, there's a lot of eyes on it across the whole company. Most of engineering will read and think about those support issues that are coming in. And if it's a performance issue, there's often someone from my team who's looking at it, trying to make sense of it, thinking about suggestions. So definitely a great, great resource. I also want to call out the knowledge base that support writes and maintains. There's tons of great performance information out there as well. I did add my email address and Clip's email address, but if you have a problem, support is the best way to go, just because there's someone always watching it, and you might email me or Clip, and who knows, we go on vacation all the time. I mean, we might not be there. So definitely call support. Yeah, definitely, exactly. And I also have a couple of white papers that I've written about these topics, so there's some reference links there for you as well. All right, so that's what we've got. We just wanted to leave some time for questions.
Hold on. Wait. Oh, jeez, I'm all mic'd.
Oh, no questions? Okay, great.
No.
I'm kidding.
Where you enabled the monitoring, can you enable different tolerances for specific ingestion flows, data flows,
Yes.
data harmonization flows, so you can monitor expected results on each individual component
Well,
of the
that's
hub?
a really good question. Yeah. So it's by app server. So it would have to be, right now we don't have that level of granularity, like if there were specific harmonization flows that you wanted to monitor for. I don't think we have that level of granularity. It's really by app server port. But certainly for ingest, like typically the ingest and you've got your staging and your final. So there's typically, you can sort of tell the difference there.
And you can
Yeah.
set the lapse time limits, right?
Absolutely.
So yeah,
You
because
can
that
set all sorts of
and that's, I think,
thresholds.
often like your harmonization stuff's going to be your long runners. So
Well, that's
yeah.
right. Like if you have 5 different harmonization flows, you may see performance issues
Right.
On one flow versus others simply
Yeah.
because of code.
Yeah, and basically you can set thresholds on any of the metrics that are in there. So there may be a way to get that granularity that you're looking for based upon knowing what your workload is like. So it's like, okay, well, I know if the write batch equals 200, that's my run flow harmonization. So that's one way you could do it, if that makes sense. Yeah.
Hi, I have 2 questions actually. On the DHF flow, how do you most efficiently do node swaps? That's the first question.
I didn't hear it again.
Node swaps. On the DHF flow, when you come to the writer, we detect certain things are coming in from the content and collector. We check for some business rules and say, hey, this node's not supposed to be there, take it out and put another node. We do several of those node swaps. And is there a way to efficiently do it better or avoid it?
So
That's
when
the
you
first
when you
question.
say a node swap in the sense of swapping nodes within the document?
Yeah.
Like
Okay.
XML nodes.
Yeah,
Yeah,
XML
yeah.
nodes. So
yeah,
that's
sorry.
the
In,
first-
in our world, nodes tends to mean the same
No.
thing as host.
No, no.
So
Yeah,
yeah,
yeah.
So that's the first question. And the second one is, in your presentation, I saw things not to do is do a sequence generator in that, the few slides before. But in our world, we are in the middle of a trading system in which the front office is pumping up trades in form of XML. And the downstream are still on relational database technologies, which relies on these unique IDs, which are longs or integers. So we have to generate these IDs because if we avoid it, all the downstream systems break.
Right.
So now we are in a catch-22, like we have to generate it for them. At the same time, it's not a best practice.
Sure.
That's
well,
my second question.
yeah. So addressing that second one first, it's just that sequential IDs are different than unique IDs, I think is what I'd say.
We are looking for sequential IDs here because they
Yeah.
are FKPK systems
Yeah.
that are downstream, and
Yeah.
we have to maintain their referential integrity. So we are off SQL or SQL RDBMS database. We are going now MarkLogic. So we don't have a necessity to maintain this sequential IDs. But if we break it, we have a cascading impact all over the firm.
Sure. And of course, that's a case. The sequential ID was an example of if you don't need one, don't do it, right? And so the idea of sequential IDs and distributed computing, it's not specific to MarkLogic in any way at all. It's just the challenge of sequential IDs and distributed computing. So I didn't mean to say that don't use sequential IDs. Of course, in this case, use case, you have to. And so then it's, then it's about making sure that you're reducing that bottleneck as much as you can.
Right.
But
in your
it's
code.
still inherently serializing your code.
Indeed.
Right. I mean,
Right.
that's as a parallel
and
computation nerd,
that's what-
I don't like
And
it.
it is what it is,
But,
like
yeah.
they say. Getting to your first question, I didn't want to forget that, is basically, so the writer is going to be one transaction. You can actually read that. You'll have that document in memory at the time that you need to do that, and you can do whatever operations you need to do to basically, what you want to do is get it into the right, the final doc format, and then do your write, rather than doing any kind of multiple writes, if possible. Of course, there's cases where you might need to do multiple writes too, and you can use multi-transactions?
You
or
could do
would that be
multi-statement
tricky in the-
transactions, but I
the
think you
context
probably
of
just wanted to
DHF?
try to do explicit in-memory operations.
As much as possible,
Yeah.
yep.
Yeah.
Anyone else?
Yeah, we got.
What do you use in the Data Hub to schedule the individual batches and jobs? Do you use the task server?
Let's see. So I believe I'm going to get mixed up on that because I've been looking at 5.0. I know 5.0. What we're using internally is our DM SDK, which is our data movement SDK. So that handles all the batching for us. I don't know the answer to
In terms of
4.3.
scheduling, I mean, I think for Data Hub
I don't
framework,
think so, but- Yep.
It is the final database for scheduling.
we can't hear the question.
No, for scheduling, it is the final database where it does it. So
Right. Well,
Yeah.
but actually scheduling the batches being run. So don't confuse the DHF Quick Start, which is the way of getting the DHF up and running quickly, with the DHF implementation. Generally, DHF customers are using an external scheduler, perhaps an orchestration tool like Apache NiFi, or they're running scheduled tasks within MarkLogic, which is less common but is out there.
Yeah, so I mean, right, but I
yeah.
think internally DM SDK has its own, I believe, its own queuing mechanism. So I don't think certainly
For
in 5.0.
queuing, but not for scheduling, though.
Right,
Yeah,
right,
yeah.
exactly. So for scheduling, you would need a different external orchestration.
Right, and,
Yeah.
and just a public service announcement, the task server is evil, please don't use it. Not quite that bad, but just keep in mind the task server queue, there's nothing backing
It adds
it.
complexity,
It adds complexity and
and it's ephemeral.
it's
Other than that, it's awesome.
Yeah, that was
queue-
the reason why I
the
was
queue is
asked
going to
this
go
question.
away, it might not be in the right place, there's all sorts of problems.
Yeah, so yes, the Data Hub should, certainly I'm thinking about 4.3 and higher when those batches, as they get written, if you have a node go down, in mid-job, it should pick up. And you may need to, I think in earlier versions, you may need to start the whole batch over again. But in later versions, I think that there's some more. But however, you might want to track down our Data Hub friends. I believe they're doing sessions here as well, so they could probably provide finer grain detail.
Right.
Sorry, I don't have all the detail there.
Any other questions? Wait. I gotta get you.
Can you put up the last slide, please, where you
Sure.
had the 2 white papers? Thank you.
There we go.
Oh, sure.
Yeah.
That's a good
I
idea.
can tell you, we are going to send a link to this presentation out to everybody in about a month. So,
But if you don't want to wait that long.
yeah, that's what
You
it
can
says
write it
here.
down
But that,
now.
Oh, wait, hold on. Later this month. So it's not a month. It's this month. So.
All right. Any more questions? Oh, we got one over here.
Do you have any suggestions for structuring your infrastructure and your kind of application installation for scalability and fault tolerance?
Good question. Do you want to take that one?
Sure. I mean, more and more customers are going to the cloud as their approach for infrastructure and fault tolerance. We're seeing less on-prem activity just because of the advantages of the cloud in terms of elastic infrastructure, being able to rent what you need rather than having to buy it up in advance and things like that. In terms of on-prem infrastructure, your best price performance is always going to be bare metal hardware. It's a question of whether you need that price performance or will virtualized approaches work.
I'm speaking, I guess, specifically towards the cloud.
Okay.
We're in cloud AWS.
Okay. I'm trying to think is there anything special about AWS just works. I mean, it delivers what it's supposed to. Same thing with Azure. It's good. We have seen customers do some creative thinking about disaster recovery in the cloud. And sort of traditional disaster recovery in the cloud would be you have one region, another region, you do database replication between the two, and you have your disaster recovery environment. People have been doing things with backups, sending backups to other regions in S3 and using that as their DR approach. We don't generally recommend that, not so much for technical purposes, but because what's going to happen to the other AWS regions if AWS loses a region? AWS has no guarantees about SLAs for provisioning new instances if that were to happen. So you may be a situation where everyone else who was trying to be clever and avoid setting up a DR environment is now also trying to stand up a DR environment in the same place.
And just one other thing to think about there, closing, is just your forest layout. So when you're replicating forests, you've got node 1, 2, 3. Don't put all the forests from 1 on 2. You want to, for the replicas, you want to split them so that if you lose a node, you don't have everything running on node 2.
Replicas, yeah.
And the good news again is if you're using the Data Hub, that topology is created for you when you create forests using Gradle.
Right, I'm going to have to wrap this up. We can
Sure.
answer a few more questions outside if you guys have a couple
Absolutely.
minutes.
Absolutely.
I just wanted to thank everybody. Thank you guys both.
Thank you
Please fill out your surveys if you can. Don't forget the spin party tonight. There's a break going on right there, so if you want to continue this discussion, that's great. And thank you all.